Hello and welcome to Edge Talks. My name is Gauri Gupta. Can learning be personalized to the needs and level of every child? In a post-pandemic world, how can technology help students make up for the learning loss? According to one study conducted in 2021, at least 82% children lost at least one specific math ability during the pandemic. And over 92% of children lost one specific language ability. While these numbers are certainly alarming, how can technology aid in personalizing learning for every child and address their learning needs at the same time? Today, we explore the role of technology in personalizing learning for every child. And joining me is our next guest on Edge Talks, Sridhar Rajagopalan. Sridhar is the co-founder and chief learning officer of Educational Initiatives, an edtech company that is on a mission to improve learning outcomes of school children. Welcome to Edge Talks, Sridhar. We wanted to demystify personalized adaptive learning, and no one better to do it than you.
Thank you, Gauri. My pleasure being here.
Sridhar, can you explain personalized adaptive learning to our viewers and how it helps children across age groups learn better?
Yeah, sure, Gauri. So basically, we find that when children are learning, and this is true whether we are talking of small children or even in middle school or higher classes, the actual way in which they learn, the pace at which they learn, the kind of errors they make, while they follow certain patterns, and that is very interesting. It's not like out of 100 children, they learn in 100 different ways. But of these 100 children, you find that there are certain patterns of learning, patterns of errors that they make. And personalized learning essentially tries to build on those patterns. One example I can take is that students, even within a topic, even within a subject like mathematics, they may be learning particular concepts better, while the same child is not learning another concept. There could be differences between language and math learning. So what personalized adaptive learning tries to do is it tries to determine where the child is. Most learning is where you're building concepts on top of each other. So if in case you find that, and this is very common in India where learning levels tend to be many grade levels below where they should actually be. So if you find that a child is not able to do subtraction properly, but he has to learn division, then for example, a software may actually take the child to the subtraction level, the subtraction questions, and make sure that they have mastered that either through questions or through activities or whatever method is being used there. But essentially, it's not a linear thing. It's not like it's a scale that you're kind of moving linearly on. It can actually be multiple paths. Something on a particular path may be a prerequisite for something on a different path. So adaptive learning basically is where you try to find out where the child is and what you need to do to get the child to the next level.
The first study on Mindspark was conducted many years back by Professor Karthik Pulidharan. And since there have been many studies across different geographies evaluating Mindspark and its impact on learning, can you summarize the evidence of what these studies are telling us about Mindspark as a solution which helps children with their learning?
Yeah, sure. Actually, there was a study even before Professor Karthik Pulidharan's study, which was done by ID Insight, but that focused on private schools. That also found that learning levels were significant. It wasn't an RCT, but subsequently, like you said, there have been a number of studies. There was one study which was done in the Delhi Mindspark centers, which is therefore an out-of-school intervention where children were coming and doing Mindspark. That was the first study. Subsequently, there has been a 3-year study for which the final paper is expected to come at the end of 2022, but the results are there. And there have been a few other studies by Convergenius and other partners. Now, briefly, what these studies are showing, and it's the JPAL study by Karthik that has been published and was the most rigorous in many ways. What these studies essentially show is that the learning improvement that is happening due to Mindspark in both language and math is very significant. It's high compared to what you normally get in educational intervention. To put it in numbers, it is about 0.37 standard deviations for mathematics and 0.23 standard deviations for language. Now, what this means in simpler language is that, so this is in the out of school, in the intervention study, where you found that the learning that children were getting in math was about double of what they would get in a similar time in a regular schooling situation. And it was 2.5 times in language. When the same thing is done within a school situation, so in a center situation, it is kind of entirely by people who are kind of helping the children do Mindspark. In a school situation, it's a little more difficult because now you're working with government school teachers, and so you are supporting them. So in those cases, the increments are about 0.22 standard deviation, which corresponds to about 80% more than what they would have learned in a similar period in a regular business as usual situation. What these essentially show is that it is possible to get what appear to be significant improvements, which are like very difficult to get if in case you had, ideas would be things like an additional teachers, or to kind of use other methods of learning like projects, or to give more material to teachers' resources. However, the improvements that you're able to get through a personalized adaptive solution like Mindspark is significantly more. In fact, Karthik said that in terms of the results, some of the improvements were better than they had seen over 15 years in various tech studies. So that is one side of it. The other interesting part is that these studies have shown that the improvements are seen across all the learning levels. So one of the things that we always check in studies like this is that who is benefiting from this. And the study, especially the Delhi Center study, showed that the improvements are kind of uniform across the groups. While the improvement is uniform, you can say that the benefits, therefore, are highest for the lowest learners, because in a normal situation, the learner at the lowest levels is kind of gaining almost zero additional learning. So everybody is benefiting. In a relative way, the student at the lowest level actually benefits the most. So this is what these studies do, and they are kind of, because they're very rigorous, it's very promising that these kind of results can be got and replicated. The only thing here is that a lot of this is based on the personalized adaptive and the pedagogical research part of it, in terms of how Mindspark is built. But this is what the studies show in summary.
Fantastic. That's very encouraging, Sridhar. And you also mentioned that you started Mindspark with it being adopted in private schools. But Mindspark today is working across many government schools as well. So what are the elements of the product that you needed to contextualize to make it relevant, to work with children in our government schools?
Yeah. Excellent question, and a lot of changes that we did as we learned along the way. We started with math. So in private schools, though we introduced English like many years later. 2016, 2017 was when we did English in the private schools. 2009 to 2016, 17, it was only maths. The first thing we realized when we started working with government schools, which was around the same time, I think by 2010, 11, we had started. So the first thing we realized was that children had a big difficulty reading. Mm-hmm. So though we were still doing math, we found that they would not be able to answer questions because they could not read the problem. So I think the very first thing we did was added voiceovers. We also made it such that the child had to choose to get the voiceover. So this now allowed us to check whether the children were asking for it and whether their performance was better when they asked for it. And of course, a lot of children were using the voiceovers a lot. And interestingly, we found that keeping everything else constant, the children's need to seek voiceovers actually reduced over a usage of Mindspark. And similarly, other tests showed that their language was improving because of doing the math Mindspark, simply because they had to read, whether it was word problems or even simpler prompts where it said solve this problem, but just the reading of that helped the language also. So the first change was that voiceovers are a constant piece, even in a math product, because you find that otherwise they're not able to solve the maths. Whereas once you kind of read out the question, they kind of, the understanding of the math and the understanding of the language were two parallel pieces. The second clear learning we realized was that we could not be only math. So the language product in the rural the government school version, where learning levels tend to be lower, got introduced like much sooner. And therefore we kind of effectively did the language product first for these children and not for the private schools. Language, we also realized, has a different approach. So in maths, one of our things is that you learn math by doing, but in the case of language, you also learn by being exposed to it. So the element of story, the element of engagement, the element of children doing something, watching something on the screen and then answering questions is much more in the language component. Whereas in math, you will find that literally every 40 seconds, the child is answering something. In language, partly true, but when they are listening to passages and there are both stuff where they have to read, but stuff where they are listening to, this may be different. One of the things we realized was that when we worked with the centers, we found that we were trying to get the children to work in Hindi, but there is a craze for English. And so parents would actually say that, why are you doing Hindi? Or why are you doing it in Hindi? Why are you not doing it in English? At the same time, as people know, it's not that the children actually know English. It's just a demand, a kind of an aspiration. And therefore, what happens in a lot of schools is, even when they are nominally English medium, actually a lot of learning happens and the teacher is talking in the regional language. So we realized that we had to do both these things. So we kind of added something which now we find has application in the private schools also, which is we actually split the screen and have the question appearing in both, typically it was English or Hindi, but actually it can be any two languages. So it may be English and Gujarati. What happened was the children would usually solve the question by looking at the Hindi or the local part of it, but everybody felt happy that it was there in English also. And in some rare cases, maybe the children actually could, like if they had come from a private school, maybe they were actually a little more comfortable with the English part. It was the same question. They could even, kind of try to use clues from both the languages if they wanted. So that was something that was done purely for this segment. But now we find that both internationally as well as with, so it's not a big deal in Indian private schools, but we find that there are contexts where you could have any two languages if that works better for the child. So just the introduction of language is something I mentioned. The third big piece I would say is the foundational learning piece. When we are working with private schools, especially when you're working with elite private schools, you find that it's safe to assume that children by grades 3 and 4, can read the question, and, with the language, they would struggle in an expected way, when you're expecting them to get to the next level. But basic reading was not an issue. So we never had a large component of foundational learning in Mindspark. That had to change significantly once we started working with government schools. So that was a third big piece where, you're looking at not just letters, but also things like fluency, like how many letters are they able to recognize in a certain amount of time.
Got it. No, very interesting. And with school closures, and the pandemic causing the learning loss that it has, what is your vision for Mindspark, right? Getting used at home? Because I do know that you launched the Mindspark app, right? So what is your vision with that as an out-of-school learning tool?
So one of the other things we noticed, when we started working with government schools, and this was not only in government schools, in the 2010, 11, 12 timeframe, we saw this happening with private schools also, is the internet-related challenges. So when Mindspark started, it was an internet-based application, and so children used to access the internet mostly from school, but they could also do it from home, and that was the way it worked. As we started working with both government schools and some areas with private schools, we realized that internet was either poor or completely unavailable, and that's how the offline solution worked. In private schools, we had a situation where children would want to use it at both places. So they're using it in school, but then they can go back and use it at home in the evening. So it's not just an offline solution, but it's an offline solution that needs synchronization. So twice a day before and after school, it gets synchronized automatically, and children can kind of work from school, but then continue in the evening if they work from home. In the government scenario, usually the home usage was not there. So the entire focus was on having the server, and we had models where that server has been a Raspberry Pi or a regular PC. So but it's a server out of which Mindspark is running. And even though they don't have home usage, we still do the synchronization because everybody else, the people who are running the program or us, are able to see the progress that way for which it is required. Now, the pandemic firstly changed all this because now there was no question of them going to the school and accessing the servers. So, and we never saw a use case where children were accessing in government schools from home, through a computer or anything else. But then when the pandemic happened and learning kind of came to a stop in schools, we realized that at least the 10-15% of children who had access to smartphones could work. And so pretty easily we were able to make the entire vernacular versions of Mindspark, which was being used by government schools, accessible through the net. And therefore, we also made changes to make it more compatible to smartphones. So again, this is an interesting debate that, we always recommend that in a learning situation, children work with larger screens. Though the teachers and their part, they can, just as well do on the mobile phone. But for children, it's good if they have a larger screen to work with. But this was a luxury during the pandemic. If parents had smartphones, that itself was good, was a great way of learning. So these were two changes we made to kind of make it more compatible, more convenient to use and more easy to use on the smartphone, the smaller screen, as well as directly being able to access on the internet.
No, that's really useful because we do see the home as becoming an important place where children can remediate, practice, self-learn in addition to what is happening in school. Sridhar, my last question to you is that EI has been working in this area of, almost developing the science of learning for a while now. Can you explain what science of learning means and its relevance to education in India, because there is not that much that is happening in this field in India?
Absolutely. We think the science of learning is, what is really coming between where we are in education today and education being able to show like significant, clear and visible learning improvements. And very, very interestingly, the same parallel, the same analogy exists in medicine also. And not many people know this. But if you go back just about 80 years or so, medicine was not what it is today. There's a nice book by a gentleman called Lewis Thomas. In fact, the book is called The Youngest Science. And he talks about how medicine developed, between or before the 1930s until the 1970s or so. And you basically find that before the 1930s, and he puts it this way, he says that if you went to a hospital, you might have benefited from the rest and the care and the nursing, but medicine played no role in your recovery. I mean, it's a pretty strong statement. Similarly, if we look at what do we use in medicine and know about in medicine today, and which of these were known before 1930, the answer surprisingly is that almost everything we know and use today was developed after 1930, whether it's a cure for the common cold or for hepatitis or anything. And the kind of medicines used before the 1930s was mercury, arsenic, and pumping nitrogen gas into you, which are all either considered just like ineffective or in some cases dangerous. So I'm giving this lengthy explanation because somewhere we feel, and just like today, if you told, there were big hospitals in 1920 also. So if you told those hospitals that, you guys just don't know medicine, they would have been like shocked. And you can actually get the sense when you read that book. In the same way, we are living and working in a pre-science of learning world in education, where, the example we use is that if 5 patients go to a doctor with fever, the doctor will not say, oh, you have fever, so take this medicine. He will ask for symptoms, he will do some tests, and he might decide that you have fever, but, just rest is enough. And you have fever and you need to be hospitalized because this is like something. So, whereas in education, if you think about it, if you find that a child is not understanding, is doing poorly in math or not understanding this topic in science, the standard remedy for everybody is practice more, do more. I'll do some more. I'll sit with you after class and do sums. And that again reminds us of the way medicine used to work. So what the science of learning is that it's simply takes a more systematic scientific approach towards this. It says that if these are the symptoms, if children are not learning, say, decimal comparison, are there causes which can be linked? And are these causes potentially different for different children who are not able to do this? Interestingly, reading is one of the areas, we don't use the term science of learning, but reading is one of the areas where the kind of research that has happened internationally on how reading happens, what are the components of it, why does fluency matter? Why does it matter that a child is able to recognize more letters in a given period of time? And how this is like strongly correlated to the extent that they are able to read well after maybe 3 years. I mean, they have found correlations between your ability to do some of these fluency tasks when you're 4 years old and your ability to learn a second language, which may be 7 years later. So, so that is science. That is where you kind of break up. You just don't say, okay, I'm going to give more practice, but you kind of identify that these could be causes, and then I can work on, and that's the power of it. The power of it is that it now tells the teacher that do this with the child, or an EdTech product or an adaptive learning software, that, this kind of activity is going to help because the child is suffering with this. So the science of learning is nothing but a scientific way to identify using the symptoms to identify the causes and then to treat them. And in medicine, because of the science of medicine, there is a framework which allows any doctor to talk to any other doctor. A doctor can say, do this test, and you can go to New York and they will recognize the test and do it properly. And then the test result will come and you can go to any other doctor. They will prescribe a medicine. You can go to any chemist anywhere in the world and they will give you the medicine. Whereas in education, the school teacher and the tuition teacher are not able to agree on your knowledge of fractions. So that is what the science of learning can do. And to us, Mindspark itself is an example. We think that the extent it has worked is because of the fact that it is based on the science of learning. Of course, fully recognizing that this is a very small part of what eventually needs to be there.
Thank you, Sridhar. That was extremely useful, and I'm sure all our viewers have learned a lot about personalized adaptive learning today, as I have. Thank you so much for being with us.
Thank you, Gauri. My pleasure. It was fun talking.
Thank you for joining us on this episode of Edge Talks. And we will be back next time with more insightful conversations with industry leaders in the education sector.